Endochondral ossification transforms hyaline cartilage into long bones during the embryonic stage. Stage 1. Hyaline cartilage, which is present in joints, enlarges, while chondrocytes, which are cartilage builders, near the diaphysis, which is the shaft of the bone, increase in size, causing the matrix to calcify. Stage 2. The fibroblasts, cells that produce collagen and fibers, develop into osteoblasts, which are bone builders. The perichondrium, which is a connective tissue that holds the cartilage together, converts into the periosteum, a dense vascular connective tissue that envelopes bones. This produces a bony collar around the cartilage. Stage 3. Blood vessels, which carry blood to tissues and organs, and the osteoblasts migrate to the center of the cartilage into the unfilled spaces left by the chondrocytes, which are called lacunae. The calcified matrix breaks down, the spongy bone then forms and replaces the osteoblasts in the primary ossification center, which is the starting point of bone formation, then develops. Stage 4. The diaphysis, which is the shaft of the bone, is filled with spongy bone, while the osteoclasts erode the central portion to create the medullary cavity, which is where bone marrow and fat are stored. This then develops into the secondary ossification center, which is where the shaft and the bodies of long bones are formed. Stage 5. The centers of the epiphysis, which are the ends of the long bones, begin to calcify. The compact bone begins to form. The functional unit of the compact bone forms, which is also known as the osteon. Stage 6. The epiphyses eventually become filled with spongy bone. A thin gap of cartilage remains exposed to the joint cavity, which is called the articular cartilage. At the metaphysis, which holds the growth plate, the epithelial plate then separates the epiphyses and diaphysis, thus creating the long bone.